Rangi e tū, papa e te koutou, tuhei tia po tātou te wherewhere tu tua whetu. Pai mārere. E rā rangatira mā, tēnā koutou, nā mā haramai rā koutou katoa. Welcome everyone to this evening's professorial lecture to be given by Professor Annika Hinze. Professor Hinze is a professor in computer science at the University of Waikato and head of the School for Computing and Mathematical Sciences. She originally studied technical mathematics, computer science and electrical engineering at the Technical Universität Berlin, Germany, and received her PhD in computer science from the Freie Universität Berlin in Germany. She joined the University of Waikato in 2003. Her research interests include location and event-based system and digital libraries. Her work in location and event-based systems is concerned with algorithmic aspects of detecting complex patterns in data, such as detecting hazard patterns in data streams from forestry workers wearing smart vests in dangerous work environments. Her research in the digital library field centres on the boundary between algorithmic processing and user interaction, such as identifying semantics of information, modelling of delivery context, and the question of how best to display information to the end user. Her research often involves cross-disciplinary contexts, involving colleagues and industry partners from science, geography, education, and Māori and Indigenous studies. She strongly believes in the benefits of collaboration, coaching and mentoring, and is enthusiastic about the power of technology to provide good in society. Ladies and gentlemen, e homa, will you please welcome to give this evening's address Professor Annika Hinze.
Tēnā koe, Vice-Chancellor. I ngā rangatira, i ngā manohere, e te whānau o te whare wānanga o Waikato, tēnā koutou katoa. E te whare, e te papa, tēnā kōrua. E te mana whenua, tēnā koutou. I ngā mate, haere atu rā. Nō reira, tēnā koutou, tēnā koutou, tēnā koutou katoa. Nō ita tiamana a hau, ko hawe rawa ko spray o ko awa. Ko te paratika, tako moana. I nāia nei, kirkiri roa, e noho ana a hau. Ko Annika Hinze, tako ingoa, tēnā tātou katoa. Whaia te iti kahorangi, ki te tūrohu koe, mehe maunga teitei. Pursue excellence. If you bow your head, let it be to a lofty mountain. Nau te raurau, nāku te raurau, ka ora ai te iwi. With your food basket and my food basket, the people will thrive. I picked these two whakatauki as a reference to attempting to solve hard problems in research and to our shared baskets of knowledge, acknowledging that in research, you never work independent or without other people around you, but always collaborating and building on each other's work. Dear colleagues, friends, oh my God, so many of you, guests, welcome again to my presentation. Ich freue mich, dass ihr da seid. I am originally from East Germany, a region called Berlin-Brandenburg, that is Berlin and its surrounding countryside. While this is Germany, I have to explain because I get asked really often, this isn't Bavaria. No Lederhosen, I'm so sorry. No Oktoberfest either. Different sort of beer, but definitely also soccer. My rivers are Havel and Spree, and I bathed in one and repeatedly fell into the other one as I was learning how to row. My Moana is the Baltic Sea, so that is at the northern coast of East Germany, and most of our family holidays were spent there. There are no mountains where I come from, but you can always go on cycling tours, that's a plus. When people ask me where I'm from, I typically say Berlin. And I've lived there for many years, but I'm actually from near Berlin, from the countryside, which is the Brandenburg area. Between high school and starting university, this happened. I will come back to this in a moment. This is my grandmother, Elizabeth. She had to leave school when she was 12, even though she loved learning, but the family finances didn't allow for her to stay any longer. When my mother Helga then wanted to go to university, all the neighbors came to talk to my grandmother, and they said, "Why would you allow her to do that? She will only get married afterwards." And my grandmother said, "Leave the girl alone. If she wants to do it, she can." My dad, Jürgen, was quite influential on my career path, rather strangely, because when choosing between pottery and computers, he said, "Nobody is doing computers in their spare time, but you can always do pottery as a hobby." So with this excellent prediction of how technology development would go, I duly enrolled in becoming an apprentice as a programmer in Rostock at the Baltic Sea. I had then originally planned to join the university in Leipzig to study cybernetics. But with the change of political system, I ended up going to the Technical Universität Berlin, where, as already said, I then studied mathematics, computer science, and electrical engineering as a sort of triple major. I then spent a year in Iceland working on farms. And coming back to Berlin, I then joined the Freie Universität Berlin to start my PhD there, part-time to being a lecturer. My PhD was on pattern detection and streaming data, but I was also part of a project that was about digital libraries together with the National Library in Frankfurt. In our information systems classes, we used Ian Witten's book, Managing Gigabytes. So naturally, I was excited in 2003 when I had the opportunity to join the world-famous Greenstone research team at Waikato. In 2009, I then went back to Berlin as a guest professor to the Humboldt University and have thus covered all 3 universities in Berlin. Like many of my peers, I had originally planned to stay only for 2 or 3 years in New Zealand, but it has now been 20 years on 1st of October. This year, the School of Computing and Mathematical Sciences is celebrating its 50 years of computing. Currently, I'm the head of the school, but I'm wearing a very different hat tonight. I would like to acknowledge the University of Waikato for joining 3 others in New Zealand who have female professors in computer science. In terms of career support, I'd like to particularly mention Ian and Pam Whitten, who invited me to Lethbridge when I was on my way from Germany to New Zealand, stopping by in Lethbridge, and then looked after me when I arrived on my own in New Zealand, having never been in the country before. I'd also like to name Margaret Jeffries, who was a very supportive colleague when I was a young lecturer and the third woman to arrive in computer science at Waikato. And lastly, there's Janice Swan, who was an excellent mentor and who always encouraged me to just get on with it. So as the theme for my presentation, I picked data in the wild to highlight the intertwining of research and the real world, whatever that might be. I will talk about 3 projects, relatively recent projects, as I guess that nobody wants to know about technology from 20 years ago. And I will also highlight some of the research done by my colleagues across the university. The projects are from areas such as digital libraries, Internet of Things, and location-based systems. The first project is Tini o Te Haketuri. In this project, we aimed to find a technology solution for hazardous work environments, particularly the forestry environment. And because this one particularly looked at forestry industry, the name of the project refers to a multitude or a swarm of guardians of the forest. This data in the wild that we're looking at here stems from remote and hazardous work environments, in this case forestry. The rates of accidents and fatalities in New Zealand forestry are way higher than in other countries. That has largely to do with the terrain, because as a consequence, you cannot use robots there to do most of the tree harvesting. It also means that most of the people who work there are engaged in manual labor. So we have workers who go for planting, cutting, cleaning, and walking each day the distance of about a marathon. So this is physically quite demanding work. They work in and next to large machinery. And they have to react quickly to any danger that occurs, such as falling trees or slipping logs. In addition, the machine operators focus very much on the work ahead of them, but also have to look at the whole environment, as they have to make sure that their activities do not endanger their colleagues on the ground. The call or the challenge to address this particular topic came from Leonie Pihama, the previous lead of Te Kotahi Research Institute, as most of the workers involved in forestry are Maori. Together with Judy Bowen and working with a range of colleagues from across the university and people from industry and collaborators, we received funding from MB to explore a technology solution for the issue. Unfortunately, at the time, and probably still, no good data set existed to analyze what happened with the accidents, what exactly, when did they happen, etc., all of those details. However, our forestry collaborators gave us 10 years' worth of accident reports that they had collected through the government's accident reporting scheme. So it wasn't quite exactly what we needed, but it allowed us a first step. Because this data was collected in the wild, as it were, not specifically for our research, it needed cleaning before it could be used for analysis. So, looking at the data, we found that really surprisingly, a lot of accidents seemed to happen on the first of the month. In fact, at first it looked as if a lot of accidents seemed to happen on Thursdays. So we had this wild theory for why Thursdays, and then it turned out that for these 10 years, just by chance, the first of the month was most often on a Thursday. So most of those accidents seem to happen on the first of the month. Still no good reason for that. We then found out that the deadline for reporting any accidents that had happened in the previous month was on the first of the month. So this is where all the accidents got put into the system. In addition, many accidents seem to happen at midnight. Why would the workers be out at midnight? Well, they weren't. Again, this system had a default value. If you didn't put in any time, it would assume midnight as the time of the accident. So overall, about 10% of the data we received had to be discarded and was found to be invalid for a number of different reasons, such as these. So of the resulting data we then looked at, we found that 70% was worker failure, whatever that would mean. And if we looked at these ones further, we identified this kind of double peak pattern. So most accidents happened in the midday and the mid-afternoon. And in looking at it, we found this is when the workers were most fatigued, right before their breaks. You might also wonder about the length of their work days. It looks here as if they're starting at 3 o'clock at night. That's not quite true, but not that far from the truth either. The workers have to travel each week to the different parts of the forest that they work in, and they often have to start at 4 a.m. in the morning to be in the forest by 6 or 7 a.m. That's why this length of workday. So because we discovered this particular pattern, we then started focusing our research on preventing fatigue. The way we thought we could solve all the world's problems, at least in 2014, was by having step counters, trackers, smart devices, you name it, right? So we started in that year with this particular research. So we thought, so could we perhaps use activity trackers in conjunction with identifying when people's reaction time is going down? Could we perhaps find a way to identify fatigue? And once we know that people are fatigued, surely we can then intervene. So we initially aimed at creating a really good data set with the help of students and a number of researchers and people who worked in forestry to have the first excellent data set that research could be done with. Well, I can tell you now that most of the data was not usable or not useful at all. But we spent a whole lot of time on this. So, for example, one student had to wear 7 different sleep trackers. And with the result that in the morning we found that each of them showed a slightly different sleep pattern. And yes, we also tried this ourselves, so it wasn't just the student who were made to wear all of these trackers. We had people wearing different trackers on each arm to detect whether people had fallen over, just with the result that one of your arms was alive and well, for the other one to be on the floor. So that didn't really work out terribly well. The different trackers didn't really agree with each other. Often, in addition, the raw data was not really available for analysis. So overall, we found that most devices collect what is easily measurable and not necessarily what is meaningful. So they're lovely. Yes, it's perfectly fine if you want to count your steps because it doesn't matter so much whether it's 50 more or 50 less, but not for the kind of research we wanted to do. In addition, we found that the workers were not terribly keen on being tracked. Guess that. So it turned out that their devices had suddenly difficulties. They were snagged on branches, they weren't charging, they got run over by a truck, or they just stopped working miraculously for 15 minutes at 3 o'clock in the afternoon. To the workers, automatic tracking looked too much like surveillance. And also, they didn't know where the data was going, so they didn't want to risk. We therefore had to change our approach. We rethought how we do the research. So instead of looking at these particular trackers, we considered which technology might be useful in these particular work environments, and what sort of data we could give back to the workers that they might actually be interested in. So we shifted our focus from the technology, as fascinating as that was, to the workers and their families. To do this, we teamed up with Nick Jessup from WorkSafe, who introduced us to forestry workers in Northland. And we were also joined by Anna Rolston and Erina Korahina from the Center for Health, who helped guide our interactions with the workers and helped us follow proper procedure. They also analyzed for us the data following Mata Rangamari. So based on the worker input that we received in this way, we then developed a sensor vest, an IoT sensor vest, that can detect cognitive and physical fatigue. Cognitive fatigue particularly applies to the workers that are using the machines, and physical fatigue is more relevant to the workers on the ground. So we selected sensors to observe heart rate variability and galvanic skin response. Heart rate variability means you can see whether your body can still react to changes in its environment, whether it's still flexible enough to react to something that happens, or whether it has become rigid and can no longer deal with whatever happens. Galvanic skin response measures whether you're well hydrated, and hydration has a lot to do with fatigue. So in addition, we identified fatigue patterns, so we could then find out whether people are doing well or should rather have a break. We developed a vest that ideally each worker would wear, and yes, if you think this looks a bit like a sports bra, that may have been the case for our research. Don't tell the guys. We then also developed a body app and a dashboard for their whānau. So the body app means that two of the workers would team up and look after each other, body up. So instead of their data potentially going to the foreperson or somewhere else, they knew it would only go to themselves and their body. And if the guys didn't want to take breaks because they really didn't want to, because they didn't need to, they thought perhaps their body needed to take a break, so they could encourage the other person, and thus they would look after each other because they knew if their colleague isn't doing well, it might kill them as well because it is too dangerous. The dashboard shows anonymized information to the families so that they could see whether the whole team was hydrating enough, whether they were fatigued, and how they were doing in general. So this way we can get the families on board to make sure that the workers set out in the morning being fit for the job they're doing. We went to Northland and gave back the data that we'd collected in the interviews and the insights that we had gathered. And we also produced something for the research community, and that is an extension of the typical software engineering process. So in this case, bringing in kaupapa Māori and adding in more activities such as more team building, early engagement with iwi, and acknowledging that there's always ongoing relationships at the end. The second project I want to talk about is called Capisco, which is Italian for I understand. In this project, we explored the meaning of words, not just looking at the words themselves, but the meaning behind them and how we could use that. Most data in organizations is unstructured. That means it's not kept in any database or in any way so you could evaluate it and analyze it. So that would, for example, be emails, tweets, feedbacks received, Excel forms, etc., etc. This is often referred to as dark data. That is, data that is not used for decision-making or business processing. Most of the dark data is text, just by its very nature. And that is, it is very similar to these. Books in libraries where, yes, of course, we can read the text, but it's not easily analyzed as they're standing there in the library, even though their content may be of interest to, let's say, humanities scholars. Digitizing these books is only the first step. So we explored now if solutions that would work for libraries or digital libraries could also work as an approach for dark data. I led a project which was funded by the Mellon Foundation, in which a number of colleagues collaborated with the Hathi Trust. The Hathi Trust has access to most of Google's books, but also books from other digital libraries. They hold more than 18 million books, and they were interested in finding new ways of accessing their content. The books in the Hathi Trust are scanned books, which brings with it its own interesting problems. Here, for example, you can see the fingers of the scanner, because probably the first million books they had were scanned by people. Now they're using robots, but problems still exist because different typefaces, etc., mean that there's still a number of OCR issues, that is, optical character recognition. So as a use case, let's please assume that you are a Maori astronomer. Like, for example, Rangi Matamua, the starman, who collaborated with us on this project. So let's say you're interested particularly in the Matariki star cluster, shown there. So Rangi told us that he typically uses a list of 200 words each in English and in Te Reo to search for, to find literature that is relevant to his research. So our motivation was to make it easier for people like Rangi to find those documents that they're interested in. So if you're searching for Matariki in the Hathi Trust, you find 2,300 results. 2,300 results are too many, because it also includes the Matariki turtle and the Maori New Year and any other things somehow having the word Matariki. At the same time, it is also not enough, as it does not look for words like Pleiades or the Seven Sisters, so it cannot look automatically for synonyms. And yes, there's OCR problems on both sides. So our idea was now to understand the context of the particular researcher and to understand which meaning of Matariki they were interested in. So if we could now translate the word Matariki within this context into the concept of the Matariki star cluster, that would allow us to also know that Pleiades is one of the synonyms. And at the same time, we could then exclude, for example, the Maori New Year. So the idea is now to look for the concept instead of the word. To do this, we created automatically a network of concepts, more than 4.5 million concepts that were interlinked with more than 100 million links in between, which is not true because it was 100 million links in between. And then we built a search interface and a search machine that would use this network. So there's two parts to doing search. One is, what do you do with the books? And so with the books, we automatically recognized which concepts they were talking about by looking at which words co-occur together. We could have done something similar for the researcher, for the search interface, but there's a person sitting there. So instead, we offered to say, these are all the concepts we have for the word that you've just entered. Which one do you mean? You might now wonder, that's quite complicated. Why do you do this? Why aren't you just Googling it? Surely that's easier. The tricky thing, of course, is that in Google, it often assumes that we're all very much alike, which is, of course, true. So they suggest the meaning that most people have in mind. Working with researchers, however, by their very nature, they often look for the meaning of a word that nobody else had in mind, or very few other people. So instead of going with, well, everybody else means this, we actually rather ask, which meaning of the word did you have in mind? Working with the concepts means we can also do search across different languages because we're not bound by the words. We're looking for the concepts behind the words. We can also analyze books using the Capisco system. So in this example, we looked at two books from Charles Dickens, and that's David Copperfield and Great Expectations. And we compared here the use of the concept of night. And what it means is we're not counting every time a character says good night, because they're not actually talking about the concept of night. We only count when people are talking about this in more than just these two words. Coming back to the beginning. Together with Auckland-based company Pinger, we looked at dark data. And for example, we looked at how to support company mergers. We identified for each of the companies which concepts their knowledge workers worked with, and we could then match them up so people could team up and work together, even though they used different words for the same concept. The third project looks at location-based data. Location-based data is data that refers to the location of the user. So that could be, at the moment, the Gapa, the University of Waikato, Hamilton, New Zealand, wherever we are right now. The name of the project has nothing to do with drinks. I'm so sorry. It is a portmanteau of two previous projects that was TIP and Digital Library. And if you somehow mush them together, you end up there. This teaches you to pick your project's names more wisely. On the other hand, it turned out to be a really memorable name. So this project was done in collaboration with Whakatohia Iwi. It was actually a long-standing collaboration before I got involved in this particular project. Whakatohia is at the east coast of the North Island in Opotiki. I was invited into this collaboration by Danny Peru, who is the Whakatohia Iwi Development Manager, and by the CMS Community Liaison Expert, Alvin Yeo. The iwi was keen for exploring mobile apps to teach their community about their customs and their history. So we collaborated ultimately in a project that was supported by MB through a Vision Mataranga capability development grant. a large number of the community was involved in the project and helped gather data and input data, and I've listed their names there. When we started, well, and still, the iwi archive looks like this. So the iwi archive is a single room in which the community is collecting documents about the history and recent developments. However, when we started, anybody who wanted to learn anything about those particular documents had to travel to Opotiki. That is from Hamilton, 4-hour drive. The iwi was quite keen to not just include information that was contained in their particular archive, but also extend and include not just written history, but also heritage, taonga, and grow its leadership in the digital space. So we co-designed 2 apps. There's the Waiata app in black. This one showcases a selection of the iwi's Waiata, the history, who wrote them, and the context. The Taku Hikoi app leads the community on a hikoi around their rohe, so you can visit different places, and at each place you can learn about the history and the customs of a particular hapu. At the close of the project last month, the iwi now owns several apps, plus a digital library with the history and further information, and this can now be accessed by the community and researchers online. Of course, under the control of the iwi, for who has access to their data. Overall, this project was driven by Mātauranga Māori and participatory design. So that meant weekly meetings, many of which were on Zoom, particularly as this was during the pandemic, but also traveling to Opotiki whenever we could. We had many discussions with all different members of the community and hapu, and of course, always shared food and good company. Using Linda Smith Indigenous research principles as a lens, us researchers learned about Mātauranga Māori in action. For example, the principle of hikanohi kitea, be a known face. It means be involved in the community, show up, and if there's anything that needs doing, you just participate and do your part. Also, titiro whakarongo kurero means perhaps the hardest thing for researchers. Sit back, wait, and listen. Listen to what everybody else has to say. Learn first about what the community is interested in before you bring forward your ideas. You can see here members of the community as they set out to record the Waiata. I know it looks like they're in a tiny little room. They promised it wasn't that tiny. So all these women came together to record all of these different Waiata, which means they had to choose the collection of Waiata, which ones they wanted to have represented. They researched the lyrics, the translation, the meaning. They looked at the composers and looked at their history. And then they recorded the Waiata that they had chosen. Anita led the data collection. We had Rangi Maria, who designed the logo, and we had Danny, who provided whakatohea kōrero. So a whole community came together to provide data for their app. The particular challenge for the researchers in this project was to ensure data sovereignty and that control over the data and the app is kept by the iwi. I will now talk you through how we achieved this with using the Tibble software. So the community collected the data and then entered these into the Tibble system via a dashboard. The Tibble app builder then does its work and creates an app. All the data is stored in the database that sits in the iwi's cloud, so they have full control over the data. The app has 3 waiata that all of us can access, and access for downloading further waiata is controlled by the iwi. The reuse of the data is now of particular concern because now it is out in the open. Everybody could potentially access the data. So how do you control something that is out in the public? We used TK labels, traditional knowledge labels, that is markers on each of the waiata and all of the data and the app itself that would label it as property of Whakatohea iwi. The app and the labels are registered in a local context hub. The local context hub was developed by Maui Hudson and his team at Tikutahi Research Institute and the international collaborators. Anyone who now wants to use any of the data can see from the labels in the context hub who they need to contact, and that Whakatohea are the people who need to be contacted before you can do anything further with the data. This is how this works for the Waiata app, but the Takuhikoi app takes it one step further. So on the Takuhikoi app, there's also data that is collected from the users. So as the community walks through each of the different landmarks, they learn about the history, but they can also engage in traditional games. So the app teaches them to do traditional games and encourages them to record themselves singing or practicing the games. So this data is then collected and stored in a digital library that is given back automatically to the community so that they have access to all the recordings, and it will add to their ongoing recording of history. So the TIPL project at Whakatohea has a number of outcomes. First and foremost, building and strengthening of community ties across the iwi and the university. It has a dashboard for data management. And the Waiata app, I'm told, is being used every day by the iwi in deciding which Waiata to sing at the marae or when practicing new Waiata. Whakatohea iwi is happy to share with any other iwi what they've learned from developing this app and collecting the data so that other iwi can use their knowledge and also create their own apps. So please do get in contact with them. The Takuhikoi app is actually more than an app. So there is 12 po that were designed, carved, painted and erected across the Whakatohea rohe. And as you walk to each of those po, you can then learn about the history of the connected hapu. And you can engage in games or Waiata. You can find these apps and others that were developed using the TIPL software in the App or Play Store. I've shown you 3 projects, which is hard to select from all the different ones I've done over the years. And this word cloud now was created from the titles and the abstracts of my publications from the last 20 years. And so you can see some of the topics in there, but lots of other topics also. The topic of my talk was data in the wild. And I hope that you have seen that data in the wild can be quite messy and unruly, and quite literally can be wild data. But I believe it's also a really interesting place to work in and to work with this data, as this is where research meets the real world. I'd like to acknowledge my students that worked with me over the last 20 years. Thank you for your trust and for your enthusiasm. I'd like to acknowledge my colleagues for being a supportive community, and the school and the university who gave me the opportunity to do this research. And I'd like to close with a change of hats and invite you to join the school next week at our Computing in the Par event, in which we showcase more research done in computing at Waikato. Thank you.
I'm not sure I deserve that applause, but tēnā koutou katoa, ko Jeff Holmes aho. My job here is just to conclude, or to tell you that the formal part of this evening is concluded. I'd like to get you all once again, even though you've only just finished clapping, to clap Annika for a marvellous presentation and the fact that we've got a female professor at Waikato finally is the thing worth celebrating. I am the Pro-Vice Chancellor for Health, Engineering, Computing and Science. I am myself a computer scientist, so I'm meant to give a sort of brief summary of the talk, but I find it quite horrifying that someone would go out and ask people what they wanted with technology rather than telling them what they need. My own work tends to involve computers I never see, people I never see, and data sets I never collect. And so it was a revelation to me sitting there listening to Annika talk about those three projects and all of the work that she does with people at the very heart of it. And so that's a commendable piece of research spanning many years, of course, and many publications in journals and conferences. I'd like to thank you all for attending. It's just a wonderful turnout here. I'm sure Annika appreciates the warm support that you've provided for her and the way, the breadth of the university that's here. It's marvellous to see. If you have, and I'm sure you do, have questions for Annika, then please take them to the bar and discuss them with her over a drink. I'm sure she'll need one. Ka kite anō. Thank you.